Yes, hello everyone, and welcome to day three of TestMu 2024. I'm pretty sure you're having a great time here and gaining some great insights. I'm Kavita Joshi, and I'll be your host for the session on seamless upgrades mastering API compatibility. Today we have with us Naresh Jain, a renowned technology and product development expert. He's known for driving transformative initiatives at companies like Jio, Amazon, Hike, Google, and many more over a brilliant career of 20 plus years. He's a serial innovator, owning products like ConfEngine and consulting business named Xnsio. We'll hear more from him as well. So, before we start the session, let me just highlight few points. There's a chat box in the right. You can go and add your queries there, and if time permits, we'll take it by the end. Also, all these sessions are being recorded and they'll be available on the Lambda Test YouTube channel. So, if in any case you need to drop off, you can surely get the recordings available. With said that, thank you so much, Naresh, for joining us, taking time to share insights, and the floor is yours.
All right. Thanks, Kavita. The pleasure is all mine. Great to meet everyone. Even though it's remote, I'm sure we'll get to interact. I'll try and keep it as interactive as possible so that you get the most out of this session. So let me quickly share my screen.
Sure.
I have a little bit of slides to set the context, and then I'll jump in and do a bit of a live demo. I think that's what most people enjoy. So let's hope that's the case. All right, here we go. Yeah, we will be talking about seamless upgrades and how we can master API compatibility testing. So let me quickly jump in. So I have a question for all of you, right? So when you release new versions of software, how do you ensure that the upgrades are as seamless as possible for your users? I'm just curious to see what kinds of tests do you actually perform to ensure this. So if you don't mind, can you put it in the chat? So just hop over to the chat and just try and answer, what kinds of tests do you perform to ensure that the upgrades are seamless for your users. I'll switch to the chat and just see what's coming up. See a lot of thumbs up. Regression testing for sure. Yeah, absolutely. Regression plus usability. Yeah, that's good. What else? Yeah, you can obviously upvote or thumbs up. Currently, we run integration tests with every upgrade. All right. Yeah, regression. So a lot of folks talk about regression testing. Yes, user acceptance testing. That's great to hear. Regression plus smoke. So again, when I'm assuming when people are referring to regression, they're mostly referring to functional regression, maybe some bit of like at least performance related stuff. Again, I'm guessing that's something important as well. So let's see, right? What is that I have been practicing? So like most of the folks said, regression testing, and specifically I'm calling out functional and visual regression testing, right? Because these days a lot of teeny meeny issues can happen with visual regression creeping in, and especially with the different varieties of devices, operating systems, screen resolutions, etc. You want to make sure that you're doing functional and visual regression across all of these combinations, right? So that's the first one. Performance testing, absolutely, right? Load test, stress test, and soak test to ensure that when you're releasing a new feature, you're not basically impacting the performance of existing features. They are not becoming unusable for your users. Privacy and security becomes extremely important, right? You don't want to have vulnerability in your software. You obviously want to ensure that from a compliance point of view, your software is still compliant. Uh, I think someone mentioned in the chat usability and accessibility testing. Both of those are extremely important as well. You want to make sure that your software is inclusive and accessible to everyone. Uh, a lot of times what these days you would also see we've been practicing is canary, where we basically release we do a gradual rollout, so we only release it to a small subset of the users, make sure that on the key metric we don't see a dip, and then we roll out to a larger audience. Or you may do a multivariant like an A/B testing kind of scenario as well, right? In some really complicated software like here at Geo, even at Amazon and other places I've worked, shadow mode testing becomes very critical, where you run the new version of the software parallel in production to the actual system, and you send the traffic to both the systems. You send the response back from the existing system, but then you baseline the new version against that, and then you make sure that on all the key parameters your software is the new version is performing as good, and then you roll it out, right? The more the critical the software, the more these things become really important. The one that I'm going to focus today, and the one that generally is very there's very little visibility around the advancements that are there today, is the versions queue testing. And again, in that, I'm going to specifically jump into a full compatibility testing using API contracts as a way to ensure, or API specifications as a way to ensure that your software is not basically when you've released a new version of the, let's say, a backend service, then all your apps continue to work as before, right? Or you release a new version of the app and you may still be doing a gradual rollout of the app, and you want to make sure that there might be new versions of the service that are released, and some may talk to the old version, some may talk to the new version, and you want to make sure that full compatibility, both backward and forward compatibility, is verified. So this is today I really want to deep dive into this aspect. The rest of them, I'm sure most of you might be familiar, but this is this last one that I want to jump into. Now, before we jump in, right, device fragmentation, again, I'm sure all of you are familiar with the problem that we have, is we have so many manufacturers of these devices, and the market is flooded with a whole combination of these devices. Not only that, like if you take Android, then you also have this Android version fragmentation that you need to deal with. And this is just some live data that we keep tracking to see what's the penetration of different versions of Android in the market, right? So as quality engineers, as people responsible for quality, we need to make sure that our software is actually tested in all these combinations, and you have a way to prioritize what your users are currently using, and make sure at least you've tested against those key versions of this, right? But this is not sufficient, right? Back in the days when I was at Hike, this was probably sufficient. But these days, one of the challenges that I'm sure you might be facing is your users don't upgrade the apps as frequently as you would have liked, right? So this is actually a real dashboard from one of the teams where we have version 3.1 that was released almost a year ago. Now we are on version 4.3, and we still see like version 3.2 has almost 28% of the users still using it. And there's a kind of a spread of users. Now it's not always easy to do a force upgrade, and so you have to from a quality point of view, you have to ensure that you continue to support at least a few versions going back, uh, so that you don't just randomly chop off your users, right? So this is again, along with fragmentation, this is another type of fragmentation that you need to be aware and you need to handle. And the last thing that you really need to worry about, and this is a snapshot from Kaeli from Kubernetes, which basically shows you that we have several versions of the same microservice running because it needs to support all kinds of combinations, and you might have like a very complex metrics of different versions of services running, and you need to make sure anytime you are releasing a new piece of software, you have done compatibility testing, both forward and backward against this combination. uh, Again, I'm sure this is something all of you are familiar with. So what I want to do is just kind of simplify the problem and then look at how do we solve this particular problem, right? I'll quickly pause here. Does this make sense to everyone? Is this something that you can relate to? Okay, cool. All right. So sounds familiar. So let's kind of try and simplify this so that we can then try and find a viable solution on this, right? So let's assume I have version one of my app. It talks to an API gateway, which then talks to, let's say, V version one of the order service. And it also talks to version one of the reservation service, right? Now version 2 comes along, and version 2 basically talks to version 2 of the order service, and it also talks to version 2 of reservation service. And at some point a new feature is required, and we release v3, and now v3 continues to work with v2 of orders. There's no change in that, but there is a change in the reservation, and so we have a v3 version of the reservation, right? And so now anytime you're releasing any new version of any one of these things, you want to make sure that this crisscross of metrics is tested, right? But that's actually too complicated, and most people won't be able to do that. And so this, in my opinion, is not a good solution to move forward, right? So I want to talk about what could be a better alternative rather than doing this permutation combination testing of all the different versions, right? But before that, let's take a quick commercial break, right? That's the most important thing, I guess, in this talk. So, hi everyone, my name is Naresh. I live in Mumbai. I don't act in Bollywood yet. Someday. Uh, like Kavita said, I started a consulting company called Xnsio, where we work with several large enterprises in terms of their digital future and engineering transformation. I also happened to start the Agile movement back in 2005 in India, and over the years, responsible for building and running several other communities in India. Uh, as part of that, I ended up building ConfEngine, which is a platform for event organizers to build and run their uh, conferences end to end. Been fortunate enough to work with a lot of these companies and kind of learn from them honestly in terms of what they are doing. And over the last 5 years, I have been fully focused on Geo, working across several different verticals and several different platforms inside Geo, trying to streamline again, great quality products there. So that's quickly about me. Now let's jump in and switch gears to a example. Okay, I'm going to try and take an example and use that as a way to explain how we can do compatibility testing without this complex permutation type of testing. And actually, it is quite simple if you think about it, and that's what my objective will be, to try and explain that with a live demo to you guys. So the example that I'm taking here is, let's say we have Lambda Mart, which is a e-commerce company. And so far, this e-commerce company did not allow users to cancel their order. So once they place the order, they are not allowed to cancel the order. However, the business has realized that they could actually make money, and they could encourage more people to order by allowing them to cancel the order. And so you can cancel the order if it is not dispatched already. If the order is not dispatched, then you have a possibility to cancel. But to avail this while placing the order, you need to basically pay an extra fees to be, to cancel, to have the option to cancel the order later, right? So that's, let's say, that's the kind of business requirement that the business has come up with. Of course, if it's a prepaid order, upon cancellation, you need to issue a full refund minus the cancellation fee that you want to keep, right? And of course, whenever cancellation happens, then the inventory needs to be adjusted accordingly, right? So if a cancellation happens, then you need to increase the inventory so others can order for that, right? Again, I've taken a very simple example that everyone will be able to relate to, but there is enough complexity in that to demonstrate the power of what you can do in terms of compatibility testing. I'm hoping this makes sense, and I'm going to move forward. So let's look at what, from a architecture point of view, right, and from a data flow point of view. Let's look at basically what the current state is before we introduce this feature, and how that would change when we introduce this feature. So let's assume I have the Lambda Mart mobile app, from where I'm basically customers can place orders. So when they place an order, let's say I have an order service and someone's going to make an API call to, basically a post on /orders, and the order and the quantity, the product ID and the quantity for several products that they want to place order would be sent as part of the request. Now this would be sent to inventory service to reserve the inventory, right? So you want to basically block this inventory. So the request would be then sent to this. Inventory service could internally check with a bunch of other services, and there could be a complex orchestration of calls that might happen here. And then once everything is good, then it will come back with a basically an ID for your reservation, and then also the list of products that you had sent. Against each product you have sent, it would come back with a status, right? Whether it's confirmed, whether it is short picked, whether it couldn't fulfill at all, etc., right? And the order service would of course do some enhancement on it, do some bookkeeping, store some data in its database, and then respond back with a order ID, which is order ID 7, with a list of products and their statuses back. Notice there's a little bit of a transformation that is done on the response, and an order ID is generated, which is different from the reservation ID. Okay, this is the current state of our software. Okay, now we want to introduce the ability for the user to cancel order if it is not dispatched, and if they have paid a fee when they basically made the reservation. So how would this change, right? So let's look at how this would change, right? So one change that would happen in the request is, if you're willing to pay a premium, then basically a cancelable flag is going to get added to the order. That is going to get stored in the order service, and then order service is simply going to get stuff from the inventory service. Inventory service is not aware of this feature. We want to keep this feature limited to, let's say, the order service. And of course, like before, it will talk to other services and come back with a response. Now when it comes back with a response, we're going to return back in the response, basically, if something is out for delivery, then the cancelable status will be false. If something is still in the placed or accepted status, then your cancelable will be true, and the order ID is as before. So whatever is highlighted in yellow is essentially what has changed, right? So this is your first placing the order flow. Now there is a cancellation flow that gets introduced. So let's say I'm going to call a patch on orders in /7. That was the ID. I'm not showing the full request here. I'm hoping it's clear. This would then result in a deletion of reservation in 87, and specifically just product 13, because that's the only one that I can actually delete at this point. And that would say, okay, order 13 is cancelled, the status is okay, I accept it. You would then look up internally, find what was the amount the user had paid for product 13, and then refund that amount, and then return back with the refund status. Okay, so this is going to be an additional flow that will get introduced in the same request, right? Is this making sense to everyone? Like, there is initially some additional parameters will be required both in the request and response. and then a new set of APIs will need to be exposed. Not necessarily new APIs, but new endpoints like patch on order and delete on reservation would need to be exposed to fulfill the cancellation. And also a new service, completely new service, a refund service which didn't exist, will need to be built out, right? Now, what might happen is each of these changes that you're looking at might happen independently, right? Like that's the power of microservices and micro front end, is you would want each of these teams to make the changes independently and deploy to production independently. And when everything is ready, you would probably toggle it on and the feature is available or visible. And until then, basically you can continue to do releases, but you could continue to do deployments, but it wouldn't be released, right? And so that's again where you might want to use feature toggles or things like that to enable that kind of a capability. But today, let's just focus on how do I now test this change, right? When this change is going to come in, how do I make sure that I can test this change? And like I said, the entire thing might not come one shot, right? It might come in increments to you. But you should be in a position, you should be able to test it and then release the portions that are there, that are available with the toggled off state. And finally, when everything is there, you would want to toggle it on. So how would you test this, and how would you ensure that your existing versions of the applications don't get impacted? Okay, that's the key question for us today. So let's jump in, and I'm going to switch gears and go into a live demo, and I'm going to show you how some of these things can be kind of facilitated, right? So quick check of time, yeah. All right. So let's jump here. So what I have is I have a project over here, which is basically just a demo project, and this has two API specifications. So I'm basically using a open API specification, which is essentially, let me just open this guy. So what you will see is that I have orders, and order has a post, which is what you had seen. And this has basically a 201 response, which is for successful order placement, right? And so if you look at the request itself, the request is taking a list of products, which is basically an array of products. And that has two required fields, ID and count, which is very similar to what we saw. And both of those are integers, right? I'm hoping this is something most people are familiar with. You know, you would have written Swagger, you would have written, some might have used Postman, which also, can generate this file for you, the Open API specification for you. And in the response, basically, you're getting back object, which is basically has ID and products mandatory. And then, ID is just an integer, and product is an array, which has ID and status as mandatory. ID is an integer and status is a string, right? So let's assume that this is a specification I have for my order service. Similarly, there is a specification for my inventory service, which does the reservation. And this is captured in this Open API specification. If you don't have an Open API specification, like I said, you can use Postman to generate it. You could use, there are several tools that can basically generate this. You can also generate it from the code, or you can use any of the proxies that are out there, like Specmatic, one of the products that I work on, has a proxy that can generate this for you. Okay. That's not the important point here. The important point is that I have effectively captured what this example that I showed you here. I've effectively captured that in form of in form of a specification, right, an Open API specification. So now, what can I do with this, right? So now I'm about to introduce this change, right? This change that we talked about. I'm about to introduce this change. So let's see how, what are the different ways someone could go do this change. One way is that, I could just kind of write a big document about the change, define all of that, define, features, user stories, define acceptance criteria, all of that stuff. And then basically a developer can start working on it, right? So that's like a code first approach. to it. The other approach is what we call as a API design first approach, where you basically say, okay, what is the change that I need to make to the API design to incorporate this particular feature, right? So again, if we go back here, we are basically saying in the request, we need to add a new field called cancelable. Okay, so let's see how easy it would be to do that, and see whether when you make these changes, whether you'll break something or not, right? So even without writing any code, I would just be able to get that feedback by building the specification, by updating the specification and seeing whether something breaks. So here I basically have a schema. It says, the product is products is required. So let's say we add cancelable also as required, and here we'll say cancelable, and that's of type boolean. You'd notice a lot of this just gets auto completed. You don't need to fully know the syntax and all of that stuff. So cancelable, basically this is a boolean type, so it's basically said, yeah, cancelable, true, right? So that's basically the request, the change in the request, right? And similarly, there is now change in the response. So let's go down to the response and say, okay, I have an ID and product, both are mandatory. In the product, I have ID and status, and I'm also saying basically cancelable is required, and I'm just going to do that and auto complete that for me. So that is the change that we are about to introduce into this service to incorporate the cancelable, at least one part of the cancelable flow, right? So I've just made this change, okay, and now I want to know that with the change that I just made, do I break backward compatibility? If the developer were to make this change, will any of the existing clients break? I'll quickly pause here and come to the screen. What do you think? Just put on your chat. Do you think this will break compatibility? What do you think? Okay, I see no, I see yes, I see yes. Okay, we don't need to second guess these things, right? What I can do is I can simply run a command, Specmatic backward compatibility check. Okay, and let's see what Specmatic has to say. Specmatic is just an open source tool that I'm using here, and it quickly ran through and it says the new contract expects a key name cancelable in the request, but it is missing from the old contract, right? So in the old contract, we did not have this key, mandatory key cancelable. And so if you introduce this, then the old applications, the old versions of the app, which are sending the request, they won't be sending cancelable, and now their request will start getting rejected, right? So this is not a backward compatible change. This is a backward breaking change, right? So what happened here? I didn't write any code, and Specmatic actually went through, analyzed this. In fact, it executed a bunch of tests in the background, and it basically did a dynamic analysis, not a static analysis, a dynamic analysis, and it told me that with this change, basically in the request, I cannot make this cancelable. Does that make sense to everyone? So let's go back and let's fix that, right? So we cannot make cancelable, required in the request. Okay. Now, if I remove that, I will run this again, and let's see what happens. And it says, yeah, this is fine. This is missing, and that's fine. In the response also we have added, but that is okay. It's an additional field. It would not break compatibility. So with this change, we are technically backward compatible, right? And so notice here, I didn't have to write a lot of code or any of that stuff. I could quickly see what my design, API design, should look like. I made the change, and I could basically validate very quickly if this change is backward compatible or not. I can flip the order, and I can also check if this is forward compatible or not, right? So how is this working, right? What is happening here? So under the hood, when I run this command, what is effectively happening is Specmatic is taking the new version of the spec and running that in service virtualization mode. Basically, it's running it as a mock, okay, or a stub server. And it's taking the old version of the spec and basically generating tests from it and hitting this stub and seeing whether all the old, whatever was there in the older version of the spec, does that continue to be successful. Those tests, those contract tests that it generates, if they are all successful, then it says, okay, it is backward compatible. Otherwise it's not backward compatible. So that's basically what's going on under the hood over here. And that's basically, with that change, we know that this is compatible and this is good. So what we will do now is we'll also give an example, so that people know what to expect when this is happening. So let me just make sure I am in the request. Okay, so this is the request. This is an example for a request. So I'm going to say cancelable. Hang on, that's not what I meant. Cancelable and true. So I'm saying cancelable true, and in the response, I would expect that basically for each of these type, we've added a new cancelable. So here we should see cancelable true. Let's say this is accepted is the status, so it should be true. And if the status is out for delivery, then the cancelable should be false. Okay. So I've just given an example. Now I'd make this change and I'd basically again check for compatibility, make sure that this is backward compatible. Everything looks good. At this point, I would basically raise a PR to the central Git repo where all the central contracts are stored. I'll explain that in a minute. And now, as a developer, so you've taken care at design time to make sure that the changes that you're introducing are backward compatible. Okay. But what is the guarantee that your developers are actually going to implement this as per what you had envisioned, right? So again, don't need to worry about that. What we can do is basically we can use these very same specifications as contract tests to enforce that the developers in fact implement this specification as you had envisioned, right? And there is no way they can break backward compatibility if you enforce this as a contract test. So let's take the same specification now, and I'm going to simply run contract test. So there is a very simple file that exists here in contract. So this is my contract test. All this is basically saying is that this is a Specmatic contract test. It basically has a bunch of where things are running, and then it basically is declaring this and starting the stub server, and then it's shutting down the stub server. Where are actual any tests? There are no tests, right? Those are tests all get generated at runtime. We will see that in a minute. So let me just run this test for you. Okay. So this will, basically start here. I'm using Spring Boot application. So it will basically start a Spring Boot application, which is my actual order service. And it will essentially go through and stub out, my inventory service, because I'm only interested in testing the contract. And notice that, the new version of the spec, updated version of the spec, is already failing, right? So it's generated these tests for me, and I have 6 tests here, and some of these tests were working earlier before I made the change, and as soon as I made the change, it stopped failing. It stopped working. It started failing. Which is good news, right? This is like test-driven development in the same way, but the beauty is without you having to write any of the tests. So now I have a bunch of these tests that are failing, and this is what becomes a good starting point for the developer, right? So now when they implement, they need to make sure that when they are done with their implementation, all these tests are passing. And that's how you ensure that the changes they are making is not breaking compatibility when they make these changes. And by isolating each of these pieces, you're ensuring that you're basically getting full focused feedback at every individual service level. So you don't need to do this full complex permutation testing, right? You can actually ensure each of those services are adhering to your backward compatible specification changes, and that way it becomes easy. You will not see any surprises towards the end. So I can, of course, let's look at what happened here quickly to just make sure we all understand this. So there is, let's come here. So there is a request to slash orders that was made, and as part of the request, we sent cancelable true, and we sent two products. Okay, and the response came back saying basically this is the ID, this is the product, and notice that basically this test has failed because it's saying cancelable was not returned, right? So of course, if you're not returning cancelable, which is a mandatory response field, then it's going to be a problem, right? So this is how the test is enforcing you to adhere to the specification or to the contract, right? So of course, I can spend 5 minutes and fix these things, but I'm hoping you get the idea, like how conveniently I've first updated the spec, then I use the spec to check backward compatibility, and then I use the same spec to basically generate contract tests for me and force the developer to adhere to the specification. All of this without really writing any code at all, right? So this is a complete no code solution, and this is completely open source. So whatever you're seeing right now is fully open source, and you can go and use this, right? So with that, I know I have last few minutes left. So let me quickly come back and just conclude. So basically what we're looking at is, I have an app which makes a request to the order service, which then talks to the inventory service. I didn't really get into Kafka and show you, but there's also like a message it sends on Kafka, and which can be used by analytics service and stuff like that. So what here for us, the system under test is the order service, and the order service has a bunch of dependencies, and this is the thing that actually drives the test, right? So what we'll do is basically in the test mode, we will replace the app with Specmatic with contract tests, which will basically take the Open API or Swagger and generate the test. For the dependency, we will be able to use again the Open API specification and stand up a stub without again writing any line of code. Same thing for Kafka. We can basically use Specmatic, Kafka mock for using async API specification. So this is slightly different from Open API. This is async API specification, which will create an in-memory topic broker for you. And it'll also do schema validations and things like that. So the test will first set expectations on the stub by itself, saying, hey, expect this request I'm about to make. Then it'll make the request to the order service, which will then talk to Specmatic, get a response back, post a message or whatever, and then validate whether the response that came back was in fact as per the specification or not, right? So this is effectively, like in a nutshell, how we are able to isolate each of the services and do contract testing around them, right? And this is what also then enforces backward compatibility. So just putting everything together, this is what we refer to as an API design first approach, where we create the Open API specification. Once we have that, we put that in the central Git repo. To get into the central Git repo itself, you will go through a linter, like a PR process, which has a linter. It has a backward compatibility testing that I just explained, which takes the old and new version and checks that against each other. Then once you review, then it gets merged. And now basically the consumers, which is basically the consumer of this service, can start their development, and they don't need to wait for the provider to be ready. They can just take the stub, and the stub will get generated by Specmatic for them. Similarly, for the provider, what you saw is I was able to take the same specification which is in Git and run that as contract tests against this. And once you're done, you can go into your CI, run the same test, and again over there, Specmatic will provide you the stub, or Specmatic will provide the contract tests for you. So this way, when you get to an integration environment, you do not see any surprises, and that clears your path to production, right? So here we are talking about shift left all the way to the design, right? Not just shift left to development, but also shift left all the way to design. And that's what basically enhances the developer experience between all the different groups. And this is all based off Git, which everyone's very familiar with. We've seen that this drastically reduces your time to market because parallel development can happen and they don't go out of sync. And also like resiliency testing on your APIs, because we do generate a lot of negative and positive tests around each of these without you having to write any of them. So that's quickly, yeah, just there is also important aspect as you can visualize now. The benefit of this is now you can visualize your dependencies and how what is dependent on what, whether it's dependent on HTTP, Kafka, etc. All of this stuff is available through an Insights server. And so this same capability is available across Kafka, gRPC, GraphQL, Redis, JDBC, and so a whole bunch of things. You can feel free to check this out. Okay. I hope I have left 5 minutes for questions. That's pretty much what I wanted to show you. So let me quickly switch screens.
Yep.
All right.
Thank you, Naresh. Thank you for that amazing session.
Sorry,
Let's
rushed,
move.
but I hope I kind of did justice to it.
For sure. Let's move on to the Q&A.
Yeah. Wow, I see a
So
lot of questions.
there's so many. So here's the first question. How do you manage backward compatibility while introducing new features in an API?
Correct. So that's exactly what I demonstrated, that I introduced a new feature, which was a cancelable feature, and I was able to, design it and validate whether my design is backward compatible, and then implement and provide tests which will ensure the backward compatibility is maintained when the developers build their code. Right. So that is how we ensure that backward compatibility is maintained as you develop new features and you improve or enhance your APIs.
Thank you. Let's move on to another question.
I see. Yeah, what are some of the best practices for deprecating old APIs, versioning without disrupting users? Yeah, this is a great question. Thanks, Atvik, for asking that. I think the challenge is that in APIs, as the APIs evolve, you also want to deprecate older versions or older, changes that you had in the APIs. Now, the big challenge is often knowing who is consuming your APIs, right? And what is that they're actually consuming as part of your APIs. So this is again exactly where I was showing, highlighting Insights, the server where you can see basically who is dependent on what. And that way you can see, okay, once you've deprecated and you give people a certain time, and if people are Specmatic starts giving them warning that you need to get off this version. And you can also visualize that, okay, at this point no one is dependent on the deprecated API and I can delete it. So again, being very data driven, using this data to make these kinds of decisions, so that way you don't disrupt any of your users. Okay.
Thank you, Naresh, for the answering. Let's move on to another one.
Yeah. What are some of the most common challenges faced during API upgrades and how can they be mitigated? I think that's exactly, again, a great question, but that's what we try to address, that as APIs evolve, how do you try and basically provide an automated test to developers to make sure that they don't break accidentally things. And if someone has to sit down and write all these tests, it is very time consuming. Second, it will they're bound to make mistakes. So this approach of automatically generating tests from the specification and using the specification to design and guide everybody seems like a very viable way of mitigating these challenges.
So let's take up the last question, Naresh, for today.
Sure. How do emerging technologies or practices impact API compatibility and upgrades? So I think again towards the end, I quickly touched upon there are a lot of new technologies from GraphQL to gRPC to now custom protocols or your own RPC based protocols and stuff like that. There's backend, there's like a lot of new protocols are coming into the market, right? And that is going to continue evolve very rapidly, especially with AI. I think this is going to get accelerated even more further. Again, if you ask me, the key thing is to kind of try and capture some of these things as a machine understandable specification, like Open API specification or Async API specification or a GraphQL file or a proto file, any of that, right? Once it's machine readable, then basically you can do a lot of stuff on top of it and it becomes more explicit. So that is basically, in my opinion, how you would try and as new technologies evolve, you can stay on top of them.
Thank you, Naresh. Once again, thank you for like giving your time and sharing these amazing insights. We have surely learned a lot through the session.
Thank you. I will be
This
at the booth in case if people want to have more questions and they want to chat with me. I'm just going to head over to the Specmatic booth and I'll be there. Happy to interact with more folks over there.
for
Okay.
sure.
Thanks,
There's just a
everyone.
small thank you so much, Naresh. This is just a small message to all the attendees. Like, if you haven't already, please do share about your favorite session or snippets learnings from this session on social media with the hashtag TestMuConf, so that like we can select winners and give away the prizes. Please, show some love.
All right. Thanks, everyone.
So thank you everyone once again. Bye bye.
Bye.